Let's see the solution to test number 19. The question is a battery with internal resistance R equal to 6 ohm is connected to a variable resistance R. If R is adjusted to get maximum power from the battery, what is the value of R? Okay, what is the value of R? The situation is shown in this figure that we have a battery or a voltage source with a voltage difference V and the internal resistance R connect to a variable resistor capital R like this, and this resistance, the resistance of the resistor can be changed because it is a variable resistance. The power that this resistance get from the battery is equal to, if we call it the PR, which is the power that R receives, is equal to IVR, where I is the current in the circuit. I is a current in the circuit, and if this current is passed to this resistor also, time the VR. VR is a voltage difference across the resistor R. Okay, so this is the power that this resistor R receive or this resistor R get from the battery. Okay. And we can also write this VR equal to IR, okay, from Ohm's law. It's I times R. So if we substitute VR equal to IR here, so we get this equal to I square R. Okay. And this I is the current that passed through the circuit is equal to the voltage difference of the battery V over the total resistance of the circuit, which is the small r plus the big R. Okay, because we have the voltage source V, and the total resistance is the sum of the internal resistance and the external resistance, like this. So we have the PR is equal to this term. Now we want to find the value of R that PR is maximum. We can use a trick from the calculus, that is, to do that we find the derivative dPR by dR, because now our variable is R. We want to know what is the value of R that PR is maximum, and then the condition for the maximum PR is that dPR by dR is equal to 0. So we try to find the value of R that dPR by dR is 0. So we have to first find the expression of dPR by dR, and we substitute this PR here. Okay. And we know that V is a constant because V is a voltage difference of the battery. So we can take V out of the differentiation here. So it means that the condition for the maximum power now is that this term is 0. Right? Because we know V is not 0. V is a voltage difference of the battery. So this term must be 0. So we have to evaluate this term. What is this term? And when we let this term equal to 0, and what is the value of R? Okay. This is a mathematical calculation. Okay. To do the derivative, this we can use the law of the derivative of the product. Okay, this term R over R plus capital R square is a product of R and 1 over R plus capital R square. So when we calculate the derivative of this term, we can do the derivative of each term in the product separately. So we may first do the derivative of R and next do the derivative of 1 over R plus R square. The derivative of R over R is just 1, right? And the derivative of this is a little bit complicated. This term, we may write this term as the d by dr of r plus capital R to minus 2, like this. And from the usual formula for the derivative, this is equal to the minus 2 of R plus capital R minus 3 and dr by dr. And again, this dr by dr go to 1, and R plus capital R to the minus 3 is 1 over R, 1 over R plus capital R to the 3, like this. So we have this term. We substitute this term to this term, so we get this expression. And then rearrange a little bit and do the arithmetic here, find the difference here. So we write this fraction like this, and then we finally get that this equal to R minus capital R over R plus capital R square. Okay. Oh, sorry, this is not square. This is cube. This is cube. This cube. Okay. Now we will use the condition for the maximum power, which means the maximum value of this. Not maximum value. The maximum power. The condition for the maximum power is that the derivative of this term is go to 0, right? So it means that we put this term, we equate this term to 0. Okay. Since we know R and capital R are not 0 because we have the internal resistance and we have the external resistance in the circuit. So R plus capital R cube, this is cube. Okay, it's not 0. So it means that if we rearrange and take this to the right hand side, it means that we multiply this term to 0 and it becomes 0. So what we must have is R minus R is 0, since this term is certainly not 0. So R minus R is 0, it means that the capital R is equal to the small r, which means that if we want to get the maximum power from the battery, the maximum power that we deliver to the external resistance R here, to have the maximum power, this resistance must be equal to the internal resistance of the battery. And in this case, the internal resistance of the battery is 6 ohm. So it means that the value of R that it will get the maximum power from the battery is equal to 6 ohm.